Hello there, this is exercise 4A. We're going to look at, I think, quite a nice, gentle reminder of all things algebra and algebraic. Certainly looking at multiplying out what I'm going to describe as polynomials. As far as you're concerned, it's like normal algebraic things. A polynomial is a posh name for something you might have seen before. So all of these here are polynomials. You'll notice there's some power, and very often there's other powers. And all you're doing is it's a collection of those things. So there's no other weird functions, I suppose, is one way of describing it. There's just normal functions that you'd expect with powers and numbers at the front. So the power, which is the highest power, we call the degree. So this is a word that we often use, or order. So order is another. You might say this here, if you look at this, the highest power here is 4. So here you might say the degree of this polynomial function is 4, or you might say it is of order 4. The leading coefficient of any particular term, this is the leading coefficient, this is 2. But it says the leading coefficient of a polynomial is the number in front of the x of the highest power. So in this case, it doesn't look like there is one, but really, of course, there is. That's 1. So the idea of this is really we're going to try to write them. First of all, we're going to rewrite these polynomials in descending powers. That means going down. So you start off with, say, x to the 4, then you have x cubed, then you have x squared. Some of these might be missing, that's fine, and then you eventually get to a number at the end. So if I was to do this first one, for instance, I'd say x to the 4. There's plus 2x cubed. There's no x squared, so the next one I write is minus x, minus 5. Now it wants its degree, so its degree is 4. And it also wants to state the leading coefficient. The leading coefficient here is, so I'm just going to write coef, because I can't be bothered writing it. Leading coefficient here is 1, because as I said, there's 1x to the 4. So I want you to do that for the other 3 examples, and I'll ask you to pause the video, and then when you're ready you can restart. So hopefully you've now done them. Here are my answers, and there you go. So the first one I'd already done for you. Make sure you've got the minuses, for instance, here, because they matter. Hopefully you got that and you've got the right answers. If not, go back and check. So polynomials, what are polynomials? To say this is a polynomial, this is actually called a quadratic polynomial. And of course we've seen lots of quadratics recently. Its highest power is 2, that makes it a quadratic. This, for instance, is a cubic. You should know that. We call it a cubic because its highest power is to the 3. A cubic polynomial. This is a quartic. Again, this might not be one you've seen before. Quartic as in looks like the word quarter, and of course quarters split things into 4. So perhaps it's no surprise this is called a quartic. You might also remember functions like of the type this, 3x minus 1. This is called a linear polynomial. Because you draw linear graphs, for instance. And when you draw those graphs, by the way, that you get straight lines. That's where the word line or linear comes from. So the next one after x to the 4, if you're thinking about it, if you get 1 x to the 5, that's called a quintic. And you'll get these weird names, probably come from Greek or Latin or something. But polynomials can only contain then terms which are, if you like, a number times by a power of x or power of y, whatever. When n is a non-negative integer, so you can't have to the power of minus 4. It's got to be proper powers. It can be to the power of 0 because this really is like x to the 0. But of course we know anything to the 0 is 1, so we don't bother writing it. But all the other terms you'll notice are proper powers. This is x to the 1. Remember this word degree then, or order, is the highest power. And remember the highest power, we often talk about its lead coefficient. Not as often as the degree of a polynomial. That's more important than this. But you know, certainly for the work you're about to do, it might become important. Multiplying them out, you should already be able to do this. We did a lot of this kind of stuff at GCSE. So you times this by this. I personally prefer this claw method rather than you might have done the smiley face method. The reason why you want the claw method is because, for instance, here you've got to times that by that, that by that, and that by that. Then you do this one by all of them. And then, of course, we're going to need to do this one by all of them as well. So you can end up with 9 things. So that's why I think smiley face method falls down here. But can you see if you can multiply them together? I'll do this first one. Now, this first one you're probably good at. I'll do this last one. So let's do x squared by x cubed. That's x to the 5. Remember to add the powers. X squared by minus 2x squared is minus 2x to the 4. X squared by the 5 is plus 5x squared. So now if we go on to the next line, lost my pencil, bear with me, oh there it is. So I'm going to do the 3x, and I've got to times by the x cubed, and that is 3x to the 4, and that's a plus because there's no minuses involved. I just realised actually I might have been better off writing that 5x squared here. Simply because there's no cubic term. I've missed that. It goes 5, 4, 3, 2. What do I mean? 2. I've left a little gap now, and it might be better. What do I get this time? 3x times by... Yeah, I'm pleased I've done it. 3x times a minus 2. Notice 3 2 is a minus 6. X cubed. And it's good. What I'm trying to do is get these in columns. 3x times by 5 is 15x. I'm actually going to write that here. Notice I've left this gap again to give me columns. And the last one is minus 1 times x cubed, so that's a minus x cubed. Minus 1 times the 2x squared is plus 2x squared. That can go here this time. And minus 1 times plus 5 is minus 5. Oh, that better go over here then. And so my final thing is x to the 5. There. I've got plus x to the 4. The good thing about this is you can see all different, the same type of terms together. Minus 7x cubed plus 7x squared. We've just got a spare 15x on its own, another minus 5. Hopefully you did the first two all right. Hopefully you didn't get confused by the big plus in the middle. Here's my answers. Just checking the one I've done. X to the 5. That looks fine. So your job is to make sure you've done the other two correctly, and if you haven't done them correctly, go back and do them for me. Functions, again, this is a bit of a weird sort of mishmash of different types of maths in this video and this exercise generally, which we'll be looking at in class. By that I mean, for instance, we're obviously looking at functions. Now, functions are something that you saw at GCSE. Now, this is function notation. Notice how you use f of x equal to some function, or g of x. Very often you use g's. Well, f because it starts, the first letter was function, so you can see why f, and then g is the next letter in the alphabet, or h very often comes up as well. And all you do is you have a rule. Normally you might write it as y equals 2x squared plus 1, for instance, and suddenly I just call f of x equals 2x squared plus 1. It's a different way of writing the same thing. You still do the same thing. You pick a value of x and you substitute it in. There is certain advantages of writing it this way. You can write different functions. You don't have y equals and then another y equals. So f of x plus g of x, and you just use a bit of common sense. I've got 2x cubed here, I've got 5x cubed here. It tells me to add them together, so I reckon I've got 7x cubed. What about my x squared? Well, I've only got, there's none here, so I've only got these ones here, so I'm going to write minus x squared. What about my x terms? And again, I've only got these ones, minus x. What about my last term, my number? I've got a 3, I've got a 7, I reckon plus 10. So you see, I'll just concentrate on getting those down there, going down in the right order. F of x minus g of x. Minus is more tricky. It might be better if I write this out. So it's 3 minus x plus 2x cubed. And it says take away 7 minus x squared plus 5x cubed. Now, I'm pleased I've done this because minus and minus, for instance, are plus. So let's just, I'm going to write 3 minus x plus 2x cubed. And I'm going to write minus 7 plus x squared. And minus sums of plus is minus again, 5x cubed. So hopefully you sussed that minus 7 minus x squared. That's the reason why I do it plus x cubed, squared. Highest power it's x cubed still. I've got 2 minus 5 of them, so I've got minus 3x cubed. Next is plus x squared. What about my x's? I've just got a single minus x. And I've got 3 minus 7 is minus 4. So hopefully that's right. And this last one's just really an example of multiplying. It doesn't say multiply, but you should know that if there's no sign between f of x and g of x, it means times the things together. So I'm going to write 3 minus x plus 2x cubed. This seems to me to be very similar to the question you saw me do just now on using the claw method on the previous slide. So I've got to multiply these together. So let's do it. 3 times 7 is 21. They're in a funny order these, so I'm not going to try to join them, keep the columns this time. 3 times minus x squared is minus 3x squared. And then 3 times the 5 is 15, and it's a plus 15x cubed. Switch to the x, minus 7x. Minus, times the minus is a plus, so that must be plus x cubed. Minus 5x to the 4. And lastly, I've got plus 14x cubed minus 2x to the 5. And my last one is that one, which is plus 10x to the 6. So quite a lot going on there. So I think highest power is x to the 6, so I've done that. I want to cross these out as you do. I've only got one term, I think, to the power 5, so minus 2x to the 5. I've only got one term, I think, to the power 4, so minus 5x to the 4. I think I've got 3 terms, so I've got 15x cubed, or 4, that's 30x cubed minus 3. I reckon I've got plus 27x. Oh no, that's 3x squared. Nearly couldn't read my own writing because I crossed it out. So I think I end up with 30x cubed. Let's just check that again. 14, 15, 30, yes. So 1, 2, 3 all gone. I think I've just got minus 3x squared minus 7x plus 21. That's a long polynomial. Let's see if it's right. 10, minus 5 plus 30. Yeah, I think I've got that right. I'm sure I've got the other ones right there a bit easier. So I'm happy with all of those. That's functions. You've got to make sure you're good at those, because in the textbook certainly they do a few of those as well. So that should be okay. Thank you.